Hey, Algebra 2, how are you guys doing? Hopefully well. It is, what day is it for you? It's not Wednesday, Thursday. It should be Thursday, and we're going to cover section 1.2. So this is a new section. There's going to be a new learning target. Highly recommend you write that down. Today, we are just talking about characteristics of function graphs, and I think we can get this whole section done in one video, all right? So we're going to start talking about functions. And in order to talk about them, we need to know exactly how to describe them. Again, we'll get into specifics later, specific functions, but right now, just what are some key things that we can talk about it. Learning target, I can identify characteristics of a function graph. Highly recommend you write that down so you know what today's notes are about. Success criteria today. You'll feel successful when you can sketch a function from a verbal description. We will do that together in our live meet after this. And also calculate average rate of change on an interval of a function graph. I have a little formula for that as well. Pause if you need to. We're moving on. So the first one we're going to talk about is just positive versus negative values of the function. If you want to write that down, but really, I would suggest getting a sketch of this right here so you know. I mean, again, it's kind of obvious, but here is our x-axis, here's our y-axis, it's a coordinate plane. Basically, anything that's above the x-axis is positive. Again, and these are all of our positive y values. And we talked about y and like f of x being interchangeable. We'll talk about that in just a second. So basically, anything above the x-axis is positive. Anything below, again, now I see negative numbers on my y-axis. Anything below here is negative. Pause if you need to. So for example, I'm just gonna draw a function. So we can talk about, oh, that did not go on the graph, did it? Didn't catch that. Okay, there we go. There's a function, you can actually see it, it doesn't go off the screen. If we had to talk about where our positive and negative values are, we could use intervals. So just like what we talked about with our domain and range, I can say, all right, on the interval from negative infinity over here, so it looks like negative infinity to -4, our function is negative, it's below the x-axis. On another interval, from the interval -4 to 1, I see that my function is positive, positively defined. On another interval, from the interval 1 to positive infinity, again, that's from 1 on, it looks like it goes down, so the rest of it is going to be negative, all right? So that's one thing, one way you could describe your function. Basically, just look at your y-axis. Is it on the top? Is it on the bottom? Positive and negative. All right. In just a second, I'm going to start using these terms. There's going to be a lot going on, but it's just a point. So if I have a function, again, I'm just kind of sketching something. I'm going to start using points and talking about A and B because we're going to be talking about on the interval from A to B, where is our function? So maybe I say this is A and this is B right here, all right? So we've got an interval from A to B. Now we are looking at this part of the graph, okay? So everything kind of between here on that interval. So again, that's kind of like our x values, our interval A to B. F of A, again, this is a function. If you input A, you're gonna get out f of A, whatever that function does to A. And if we don't know what the function is, again, here I'm just sketching it, we can just say f of A, all right? So here, if this is A, then f of A, according to my little sketch here, would be about right here. Because that point, when x equals A, I know this is kind of odd to think about, but when we have some sort of interval, again here on this, maybe A is -5, then here you've got a point A, comma, f of A, okay? So, and then on the other hand, you've got like a point B, or you got an x value B. F of B would kind of be up right there, all right? So this would be the point B, comma, F of B. I just want you to know that when I'm talking about this, I'm talking about points on a function, and that's kind of being defined by my interval here, all right? So let's move on to the next thing, because we're going to use these ideas of A and F of A and B and F of B. All right, increasing versus decreasing, another characteristic that we can use to describe our functions. So, when is it increasing, when is it decreasing? Here is the kind of technical definition of function increasing and decreasing. But I just want to let you know that we read left to right. So, right here, are we increasing? Again, I'm reading left to right, so I'm reading left to right on this x-axis. I'm increasing, I hit this point, and now, again, going left to right, it looks like it decreases. So my function is decreasing on the interval from -1 to 1. And then we hit this kind of turning point, and on the interval from 1 to positive infinity, all right, now I'm increasing forever. So this technical definition says on the interval A to B, where B is greater than A. So let's just pick an interval for this graph. I'm going to say, I'm going to use this kind of middle place where it's looking like we're decreasing. So I'm going to use this interval between -1 and 1. So so when I have like my interval at -1, is my function positive at -1? Yes, it is, because it's up here above the x-axis, right? So up here, I'm just going to call this A. So this point would have to be A, F of A. And if I let down here, this is like my other side of the interval, B. Whereas my function, well, when it hits here, my function is down here. So this point, I could even just call it B, F of B. All right, so I've kind of got 2 points here, and now just by the definition it says we are increasing if F of B is greater than F of A. So I look over here, F of B kind of looks like about -3. I know, just bear with me, this is kind of confusing. So my F of B, my like Y, is like -3 here. But my F of A up here is about +3. So my F of B, this guy down here, it's smaller than F of A, therefore we're decreasing. If F of B is smaller than F of A, then we're decreasing, all right? Just kind of read left to right, see if you're increasing or decreasing. But I do want you to be able to kind of understand what this definition is saying. Okay, we'll go over some more of these. Don't worry too much, all right? Just know that, okay, I'm increasing, I'm increasing, I'm increasing. Now I'm decreasing, now I'm increasing. That's basically it. Okay, average rate of change using 2 points. All right, so again, those kind of ideas of we're looking on the interval from A to B. Again, A to B could be anything. In the last example, we had the interval A to B, it was -1 to 1, right? So again, we're using kind of 2 points here. We're getting that notation in our brain. The average rate of change formula is that. Hint, hint, it's really just the slope formula from like Algebra 1. All right, you remember y2 minus y1 over x2 minus x1? It's pretty much the same thing, but in a different packaging. So you could even think about it like that, right? So, again, take a second if you need to write that down. If I'm looking at this function, and let's just say I want to find the average rate of change between the interval 0 to 9. So I'm looking at the interval 0 to 9. Okay, I see that it's increasing, and then at points it starts decreasing, and then it increases again, and it kind of decreases, and then it increases. there's a lot of different changes going on there. But I just want to know, on average, what's the rate of change? On average, what's the slope, right? Basically, we're trying to find this slope from this point up here, okay? Basically, that's all it is. That's what this is saying in just a different packaging. So if I want to use these 2 points, I can look at these 2 points where my function is defined on this interval. So my first point would be down here at 0, -7. And my second point up here is at 9, 3. All right, so again, this is kind of like our A and f of a, and maybe you want to even write that down there. So this is our A, and this is f of a. I'm making that little note. And here is the second interval. Oh, can you see that? Yes, you can. So maybe this is like B and f of b, okay? Now we're just going to take those 2 points and use the slope formula, use the average rate of change formula. So we could do f of b. Again, this is like my second y coordinate. So if I look over here, my y coordinate over there is 3. So I can say 3 minus f of a. This is like the y coordinate from my first point. So my y coordinate over here is -7. 3 minus -7 over, and now we're looking at the interval numbers. So these are kind of like our x coordinates from our points that we chose. So here my b would be 9. Again, I'm looking at the x coordinate from my second point over there. 9 minus, and then a, right? The first x coordinate is kind of like 0. And then you can just kind of solve that. This is, I mean, we're really just finding the slope between it, right? Again, there's not a nice slope here because it's going up and down, positive and negative, increasing and decreasing. But we can just find an average rate of change between these 2 points, all right? So 3 minus -7, I see 2 negatives, I like to just put positive there, call that 10 over 9, so 10/9. And if you think about it, that's a positive slope. From going down here to up here, are we increasing? Yeah. I mean, again, we're increasing and decreasing at the same time, but just in general, to get down here, to all the way up there, you're increasing with a slope of 10 over 9. So that's kind of average rate of change. I'm going to do one more example with this formula. Okay. So here, I have the function y equals x squared. I could even say f of x equals x squared. Get used to that notation, all right? And I want to find the average rate of change on this function on the interval -3 to 1. So I'm going to pick purple. So I'm going to go to -3 to 1. So I'm going to look at where the function is on those 2 x values. So here at -3, there it is, my function hits right here. And here at +1, my function hits right there. Let's get those 2 points and find the average rate of change. So here I'm at -3, +9. So I'm even just going to write that down here, -3, +9. Over here I'm at 1, 1. If you'd like to, using that formula, go and just write A, f of a, B, f of b. So you have those to look at, all right? And then you just use that little formula. We're using the slope formula, really, okay? So I can say my f of b, I'm going to write it out just so we have it. And then just plug in some information from the points, okay? So f of b, the y coordinate, or my f of x, right? Sorry, it's the y coordinate for my second point. So here, 1. So I've got 1 minus 9, that's the y coordinate from my first point. over, and then what is the x-coordinate from my second point over here? We've got 1 minus -3. All right, and then just kind of finish that off here. On the top, I've got -8. I've got 2 negatives, so I'm going to make those positive, and then I've got over 4. And then I can simplify that down to one number and say my average rate of change for this function on the interval -3 to 1, decreasing, all right? It's a -2. I've got like a downward slope. So from here to here, again, even though we're decreasing a lot, and then at the very end we're increasing, the average rate of change over that entire thing in general is just -2. So again, to get from here to here, we are going down, right? All right. I think that was the hardest thing to think about for this section. If you need to go back a few seconds and pause and get that down, feel free to do that. All right. So just a little review, increasing versus decreasing on the interval from -5 to -2. Let's look at this graph. So from -5 to -2 is about right here. Are we increasing or decreasing? Neither, right? We're not going up, we're not going down. So we could just kind of say that this is constant. There's no change. What about on the interval from -2 to 1? So here's -2 over to 1, all right? So now we're looking at this little chunk here. Well, definitely decreasing, okay? I'm gonna write these over off to the side. So here I'm gonna say neither, no change. And again, if you'd like to get a sketch of this graph, highly encourage that. Follow the example with me. From -2 to 1, we're decreasing. From 1 to 2, okay, now it's just this little blurb. It's kind of small to see on the YouTube screen, I'm sure, but this little here, we're increasing, and we're increasing at a faster rate of change than we are here. Would you agree? Again, they're both increasing. So I'm going to say here we're increasing. On the next interval from 2 to 8, again, we're increasing as well. But the difference between these two intervals is I would say that from 1 to 2, we're increasing a lot. It has a higher rate of change. It's kind of got like a higher slope if you want to think about it, versus this interval from 2 to 8, which is, it's a little shallower, right? It's not as steep right here. Okay, that was our good example. Local maximum and minimum value. I'm saying local because later we're going to get into global maximums and global minimums, but just for this right now, I really hope this is self-explanatory, but you could say, look at, I'm going to say for here, look at your y values, y or your f of x values. All right, so because we could say that the minimum value for like our x value is down here at -5 and our maximum is 8, that's not really super interesting. So when we are talking about minimums and maximums, we're always looking at that y-axis. So here I've got a minimum at -1. Okay, so my minimum value would be at -1. We could even say that it's at the point 1, -1. For our maximum value, well, definitely going to be this guy up here. That's the highest point on my y-axis. So we could say that that maximum value is at 4. Or you could even just pick the point out, right? We've got that maximum value of a maximum point at 8, 4. So those hopefully should be pretty self-explanatory. Local minimum and local maximum values. We're getting there, we're getting there. We are definitely going to talk more about zeros, but just so you know, the zeros of a function are each value of x for which f of x equals 0. Breaking that down, zeros are values of x which for which f of x equals 0. So it's a value of x such that y is equal to 0, right? F of x, or be thinking about your y coordinate. So on this graph, where is y equal to 0? Okay, if you're looking up here, y is positive, y is negative down here. So when y equals 0, it's got to be along the x-axis. So when you think about zeros, be looking on the x-axis, okay? So I've got a 0 right here, and I have another 0 right here. That's where the function crosses the x-axis. That's where my y equals 0, all right? So here I'm going to say that it's about 1.5. So I have this first point is at 1.5, comma 0. And I'm going to say that the other one crosses at about the origin, 0, 0. All right, again, here, notice that your y's are both 0. So I'm going to say 0 a lot. My zeros of the function are going to be considered my x values. So I have a 0 at 0, and I have a 0 at 1.5. So my zeros for this function would be at 0 and 1.5, 1.5. All right, rocking on, you're doing good. Okay, this is the last slide. You're hanging with me? This is awesome, all right? So I got a little roller coaster thing here. This is also on page 17 of your textbook. If you'd like to look at that right now, you can follow along with me. We've got this graph. It is indicating time in seconds, elevation in feet. We're talking about a roller coaster. Before we start dissecting this, I want you to know that just because the graph looks like a roller coaster doesn't mean that all graphs are going to represent a situation visually. So we may see graphs that look like this, and they're talking about speed of a car or distance of a car. You just have to make sure you're using those axes, whatever their description is, and thinking critically about it. But here is kind of easy because we're talking about the time, how long you're on that roller coaster, and your elevation. So it's going to kind of match a roller coaster track right here. I'm going to go through each of these bubbles real quick and we'll talk about it. What are the units and scales of these axes? We've already talked about that. Elevation in feet, how high you're off the ground, and time in seconds. So as the roller coaster keeps rolling, how high are you getting at those points? Here, how does the description of the scenario allow you to identify important values on this graph? I think this one right here is just trying to bring us to this maximum point. We talked about local maximums and local minimums. We'd probably have a local minimum down here at 0, our local maximum up here at maybe about 220, 215, somewhere in there. All right, that would be like the top point of your roller coaster before you do that scary dip. Here we go. Why is this part of the graph horizontal? So if you see from 0 to 40, there's nothing. There's no change, right? We're not increasing or decreasing. We're staying the same. And if you think about that, I'm thinking like California Screamer. You've got that, you go really, really fast. I don't like roller coasters, so I don't have a good description, but you got to build up speed. You're going really, really fast. You're staying at sea level, right? You have no elevation off the ground. You're just here boarding, and then you go really, really fast. We hit this point, and now we're starting to increase, right? We're starting to increase, going up and up and up. We hit this point, and then we drop, okay? Our elevation drops in a very small period because we're going down really fast. Okay. Last question here, how do the average rates of change of the two greatest drops compare? So again, I've got a drop right here and a drop right here. It looks like they probably take about the same time to drop here. But just looking at this, going from here to here, is that going to be steeper and have a higher average rate of change than going from here to here? Obviously, this is a bigger drop. And this is a bigger drop than this one. So this first one is going to have a higher average rate of change. Clocking in at about 25 minutes. You guys are doing great. Let me know if you have any questions. I will see you in the Google Meet at Blackman 107. We'll go over some examples. I'll take some questions. You did good today. Meet me in 35 minutes. Blackman 107. Yay!